Okay, so recursive function is a function which is capable of calling itself is called recursive function. So for example, if we see suppose factorial is there. Okay, so in factorial we are calculating suppose def fact, and here I'm taking num as input, and I'm just checking um, if
Your screen
num
is not
is
visible.
oh, okay, okay, okay. Is it visible now?
Yes.
Okay. So, factorial is a we are calculating a factorial.
Okay.
So, factorial simply we
Not
are
yet. It is not visible yet.
again not visible.
Yes.
Is it now?
Yes. Yes.
So, here I am taking this if num is equal to 1, then return 1, else return um num into fact of num minus 1. Okay, and then I am taking an input. So val is equal to integer input, enter the number for factorial, and here I am taking this as input, and I am passing print final factorial value is, and here I am calling fact of val. Okay, and I'm executing this. Okay, this colon is required over here, and calculating this 5, and it is returning me 120. Okay, so here this is recursion, right? Recursive function, you can see this is a fact function, and inside the body of this fact function I am calling the same function again. Okay. Okay, Sharmila.
Sorry, I was talking on mute. Yes.
So you can see here inside this function, the function has been called again inside. So this is what is known as the recursive function. So in recursion, basically what it does is it keeps repeating the process till this condition is true, and once this till this condition is false, and once this condition is true, it starts returning the value. So how is it calculating? So, just for your understanding, first of all, suppose 5 has been entered in the input. So, val is equal to 5 at initial space, right? Now, what it will do, val will be passed over here. Okay. With this val, so at initially, when this function is called, num value will also be 5. Okay. Now this will be checked if num is equal to num, sorry. So, so here what it will do is if num is equal to 1, so this condition will become false. So what it will do is it in this case it will return this part. So in this part, what is there? 5 into again fact of num minus 1, that is 4. Okay. So now you can see this fact, the same function will be called for fact is equal to 4, right? So now here in this calling, num value will be 4. Okay. So now num is equal to 1. This will become false. This will become false, and it will return 5 into Now, this will be called, now for fact of 4, it will be called. So this will be 4 into fact of 3. Okay. So now here value of num is 3. Now for 3, it will be called. So num is equal to 1. So this is also false. So here it will be 3 into fact of 3, fact of 2. Okay. So and now this here num is equal to 2. Now for num is equal to 1, it will be called as false, and here it will be considered as 2 into fact of 1. Okay, once this is considered, now here num is equal to 1. When this will come, now this condition will check again, num is equal to 1. This is becoming true now. Once this value is true, what will happen? It will return 1. Okay, from here this will return 1. Once this will return 1, this 1 will go over here. Okay, understood? So now this 2 into fact 1. So now value of fact 1 is 1. So 2 into 1, this will become 2. Now this 2 value will return here. Okay. So what it will do? 3 into fact of 2. This value will be 3 into 2. This will return 6. Now this 6 will go here. Okay. So this will be 4 into fact of 3. So fact of 3 value is 4 into 6. It is 24, right? So now this 24 will go here. Okay, and this will be 5 into fact of 4. So fact of 4 is 5 into 24. This will become 120. And this 120 will go here, and finally it will return the value this as 120. Understood this?
Yes.
Okay, so it is again step-by-step calculation of recursion, where this stack process works, and the previous numbers will be stored until the further numbers are getting calculated finally. Okay, once it gets the full value, it will start returning from where these values has been called. Okay. So this is what is being considered in case of recursion. So recursion is very useful when you will be making the programs which has the high level of logics are there. You can use recursion very well in those cases. Okay, is it clear?
Yes.
Any doubt in this?
No.
Okay, so this is recursion. You can use recursion wherever you need. Like if you want to make the Fibonacci series program, you can make the Fibonacci series also. All right. So do you know what is Fibonacci series?
Yes. Last class you have taken.
Yes. So you can make the program of Fibonacci series. I'll just made this part as comment. Otherwise, this will be issue. Okay. So now let's see if for Fibonacci series, if you want to make Fibonacci series. So let's see Fibonacci series with recursion. So in Fibonacci series, how series works? Let's just judge once. 0, 1, 1, 2, 3, 5, 8, 11, then 19, and No, no, 11, not here. This is 13, 13, 8, 21, and 34. Like this, it goes, right? So, what it is doing is, for example, if now in what we are doing, define. Um, Shamila, can you please mute yourself?
Okay,
There is some background noises there.
okay,
Fibonacci series, and I am taking num as input over here, and what I'm doing is return uh, num if num is less than or equal to 1. अगर number यहाँ से कम है, then we'll do else. Else simply will do Fibonacci of um, num minus 1 plus um, Fibonacci of num minus 2. Okay, this is what we are doing, and we are repeating it till 10 terms. So terms is equal to, suppose we'll take 15 and print Fibonacci series is as follows, and then we are for num in range terms, and here I'm calling just Fibonacci. Print Fibonacci. Okay. Okay, so you can see here now it is printing like this. Okay, understood? Unmute yourself when you speak.
oh, sorry. Yes, yes.
Yes. So this is how you can print. Now, I want you to think something. So now you can see here, it is printing like this. Means every number in one line, it is new line, it is printing. I want this to be printed in same line. Can you do the changes in program and tell me how to do that?
So once again, tell me what you said.
So now, right now, you are seeing the output as it is printing everything in new line. This is a new line. This is a new line. This is a new line. Right? I don't want to print it like this. I want to print it like this. In one line, all I want to print the entire series. Can you help me to do that? If you want, you can unmute yourself and tell me how to do that. Tell me how can we do this?
Can you show the program? Yes, we will do with,
Hmm?
we can do with,
Your voice is breaking. Your voice is not proper.
so we can do with that flower bracket, right? So we usually do that format, print with the format.
Your voice is not clear.
Okay, 1 minute. We can do it by format, right? Okay,
No, not by format. The simple solution for it is store this in a list, right? So I am taking fib list. I am taking as a blank list. I am taking. Okay. Now what I am doing is fib underscore list dot append, and here I am calling Fibonacci, and with num I am calling this. Okay, and then finally I am printing print fib list fib underscore list. I'm just calling this is fib 5b. Okay, now you can see this is coming like this. Okay, clear.
yes.
Same thing I'm doing with the list. So I'm storing all the numbers into the list, and that's what we are doing just. And it is printing in form of in a single line. Everything is being printed in a single line. So if you want to do it, suppose till 30, so you can do it till 30 also. You can see with 30 how much big number it has increased. Okay. So this is the way you can use the recursion for your program. So recursion is very useful when you will be doing very high level programming like DSA programming and all. When you are going to do, you can do this. You can use the recursion program. It comparatively reduces the code of length very much, so that your code may look not too much messy, and you need to write very less number of programs, although the interpretation of recursion is a little tedious, but it reduces the program length, and it provides you a cleaner code. Okay, now the next part in this is what we are supposed to do is numpy and pandas. Okay, so our core Python part is almost over. Now we are leading towards a small implementation parts in this. Okay. So NumPy and Pandas are specifically the data science related packages, and they are being used for better handling of the data and numbers and all. Okay. So first of all, there are two packages. One is NumPy and another is Panda. So to to execute this, where it is, yes. Um, hmm. So let me start a new program now. NumPy, just NumPy I'll take. Okay, so NumPy is basically it is nothing but array which has been developed by Python community, which handles the most of the mathematical function in much faster way, right? So basically when we do some operation in the numpy, so the numpy array process them faster. So how faster it is there, I have made a demo over here. So you can see I am creating a list which size is around 10 million. Okay, 10 million size of list is there, and I am doing process of those 10 million list with the help of Python list, and with the help of NumPy version. So how NumPy version is defined will come onto that. I am just giving demo that how much faster a NumPy version is. Okay, So what I am doing is I am recording a time at the start of this and I am recording a time at the stop of this. So this is the returning time has been calculated. So how much time has been taken by this, it has been calculated. The same thing I am doing with NumPy version. This is the starting time and the stopping time I am taking, and both time has been returned. And what process we are doing? We are making two lists over here of 10 million members each, and we are just adding the numbers together. Okay, so first index number will be added with the first index, second with second, third with third. Like that, numbers will be added. So 10 million records are there that are being added with the pure Python version, and the same 10 million records are assigned in the NumPy version also. So here, size of vector, you can see I have already defined the size of vector. The same number of size is created here as well. And now what we are doing is we are just calculating how much time they are taking, and at the last we are checking how much faster it is. So Python time divided by the NumPy time I am taking. Okay, so here I am just dividing it. So it will take time around 1 minute. It depends that how much condition is available. So based on that, it will return me the time. Okay, so usually it is 50 to 60 times faster. Now, why it is 50, 60 times faster? That is because of its memory allocation. Okay, so till this gets execute, I'll show you how these memories are allocated. So suppose I'm taking my list is equal to I'm taking 5, 6, 7, 8. I have taken. Okay, so if you check the ID of my list, so do you remember the ID function? Do you remember the ID function?
ID, I, ID, I don't. Did you take ID?
So ID function is basically to to find the memory location memory location of any variable. So in any value. Okay, so where it has been stored inside the memory, we calculate through ID. Okay, so let's see how ID what is the ID value of this in our scenario. Okay, then here I'm taking print ID of my list of 0. Okay, and then I am taking print ID of my list of 1. I'm just checking this. Okay, now what I'm doing is I am storing the same list into the into this. Suppose let's take another value. Um, NPARR is equal to n np dot array import numpy as import numpy as np I am taking, and np array is equal to np dot arr, and here I'm just taking my list. Okay, so my list is now converted to numpy array, sorry, npa array. My list has to be executed first, and here I'm executing. Now I'm seeing the memory location of this. So I'm just, and here np array I'm taking np array, np array, np array. So you can see the memory location over here. You can see the memory location here. This is 2976. This is 5008. This is 5040. Right. So they are locating at some farther place. While if you see the memory location of NP array, it is comparatively they are getting located at some nearer places, right? Let's suppose I am taking np dot a range, and I am taking this up to 10. Okay, and I'm executing this. So you can see here, it is they are storing at very nearby places, while in here they are being stored at some distant places, and that's the reason there is delays there. So you can see here overall, the pure Python version has taken the 96 second in execution, while NumPy version took the same execution in just 1.3 seconds. This is 96.765 seconds, and this is just 1.3 seconds. So how much faster it is? It is 73 times faster, right?
How,
Now
where are
every
you showing? I don't see it.
um is my screen not changing?
No.
Visible now?
Yes.
Yes, so you can see here, this is pure Python version took 96 seconds in execution, while NumPy version took only 1.3 seconds in execution. And the NumPy version seems to be 73 times faster than the pure Python version. Okay. Yes, no.
Yes. So you execute the program, it is showing the result.
Yes, yeah, I executed this entire program, and this took around because 10 million records were there, so this took around 96 seconds, and this took just 1.3 second.
Okay.
Okay, so that's why we can say this NumPy version is how much faster. Okay. If you want, you can start, you can try executing the second time as well. So it's not necessarily that every time it will be 73 times faster. Sometimes it can be more faster, sometimes it can be less faster based on the system's availability. But one thing for sure is the NumPy version is way more faster than the core Python programs. Okay, so that's why whenever we are doing some execution in Python, so we always prefer the NumPy for this. Okay, now um, how we can import the NumPy? So this is NumPy. Import NumPy as NPV we will use, and suppose we have a list like this, so it is still executing. So that's why I'm not executing anything over here. It is still executing. It is still taking time. Okay, so first of all, there is my list is I am taking the initial one. This is the list. Now, when if I have to convert this list into NumPy array, what I have to do is np dot array is the command which will help to convert any list into NumPy array. Okay, so this is my list. My list is converted to np dot array my list, and print array this okay, so here this is executed. Now this time you can see it is 58 time faster. It took 81 seconds, and this is 1.38 seconds. Now I'll continue with this. So here I executed this. This is list, and now I'm converting this list into NumPy array. So this is np.array I'm using to convert any list into NumPy array. The same thing you can do with tuple also. If tuple is there, if you want to convert it into the NumPy array, you can do the same thing with that part as well. Okay. Then type type ARR. So if you will check the type of this ARR, it will show that this is NumPy ND array. Okay. In the same way, you can create the two-dimension NumPy array as well. So here I am creating a two-dimension list and I am executing this. And when I'm converting np dot array and I'm supplying this mymat over here, so this two-dimension list is converted to two-dimension array in NumPy. So you can see the basic visible difference. So NumPy two-dimension list is showing like this, and two-dimension NumPy array is visible like this. Okay, is it clear?
I have to try.
Is it clear for you?
Yes, yes,
Okay.
for sure. I have to try.
Yes, I'll share the entire document after this. I'll just save it right away and then I'll share. So py I'm saving and I'll share it right away after the class. You can refer it.
I need a recording also. I cannot download it from YouTube.
Sorry,
So I need a recording also because I'm not able to download it from the YouTube. When I'm going, see, my situation is
you
different. So, oh,
in
I cannot
from
watch
YouTube you
from
don't need
YouTube
to
anytime.
download. From YouTube you don't need to download. You can directly watch on YouTube channel. It will always be there on YouTube.
No, no, no. Yeah, my situation is different. I'll be outside most of the time, so I cannot watch it from YouTube. So I will be downloading it and keeping it handy, as I told you already. So it would be much better for me, much helpful for me if you share it with the link you already send it to me, like the same
So
way you send it. See, last time they have I'm unable to open the link and then they have shared the YouTube video as you said. But most of the time I'll be out. There are so many things I will take care. So I'll be out. I cannot watch it from YouTube. So if it is handy with me, it will save my time. So
okay. Actually, I'll share the recording link after 1 hour of the class. Once you get the recording, you can download then and there itself.
okay,
Otherwise,
okay.
from the server side, it gets uploaded to the YouTube in just 24 hours. And once it is uploaded into 24 hours on the YouTube, it is automatically dropped from the server because of the space saving.
Oh, got it. Okay, this I don't know. Okay. Okay, I will as soon as you share me the link, I will download it.
Yes.
Okay.
Okay. So now, once you have created the NumPy array, what you can do is you can just check the attributes of this. So, like, what is the shape of the array? So you can use NumPy array dot shape. So you will get the shape of that array. How many dimensions are there? One dimension or two dimension? You can check with that. If you want to check the type of array, you can use just type function. So it will show you that this is NumPy array. Okay, but if you want to see if it is integer array or other array, so you can check as d type, right? So d type will show whether this is an integer array or other array. So just one thing to remember is that a numpy array do not contain all the elements together. Like list has the string also, list has the number also, list has the float value also, but the numpy array do not contain everything together. So if you try to if you try to make, suppose I am making a list, my list I am making it like 4 7 9, and then I'm taking 8 comma B, and then I'm taking 7.89. Like this, I am making. Okay. Now, if I am converting this to NumPy array, so NPARR is equal to NP dot array, and I'm converting, now I'm using this my list over here, right? If now I print my list and I am printing NPARR, so you can see visibly that here this is the my list, but here it is showing it like this, right? So you can see here in 479 also it is it has taken the single inverted comma. So it has converted all the values into characters, right? So if you give the multiple data types in NumPy array, it will convert all data types into the one in which all data types can be converted. So for example, if suppose you have given the integer and string, so everything will be converted to string. If you have given integer and float, so everything will be converted to float. If you have given float and string, so everything will be converted to string. And let's suppose you have given integer and boolean, right? So everything will be converted to integer, right? So it does not entertain the multiple data types together. Clear?
Okay.
Okay, so for example, if I am taking my list is equal to, and I'm taking 4 comma 6 comma false comma 4 comma 5 comma true. Okay, I'm taking it like this. Okay, now when I'm converting, NPARR is equal to NP dot array, and I am taking my list. And when I'll be printing this print, I'll check the type also. So type of my list. Okay, and here I'm checking type of NPARR, and another thing, NPARR dot D type. Okay, so now you can see here. Here I gave this false, so it is giving me 0, and here it was true, so it is giving me 1. An entire array is converted into integer. Okay,
Okay.
so the point to be noticed is that the NumPy does not NumPy do not entertain the multiple data types together. Okay, this you have to keep in mind. Okay,
Okay.
so now there are some ways of initialization are there. So for one of them is that a range, like we were using the range function, right? In the same way, in NumPy there is a range function. So similar to range, NumPy array in NumPy array we are using the a range. Suppose I have given 0 to 15, so it will create an array starting from 0 till 14, right? I have given np dot a range 0 to 20 comma 2, so it will take number from 0 to 19 and jumping by 2. So 0 to 4 8 6 8 means 2 jumping will be there. Okay, and then I have taken this np dot zeros, so it has created a array of 8 zeros. I have taken np dot one, so it has created array of ones, 5 ones of array is created. Okay, if I am creating the two-dimension array of zeros, so 2 comma 3, so it has created this array. Uh, Okay, then np dot ones 3 comma 4, so 3 rows and 4 columns it has created. Okay, so these are few predefined names with the array, whichever you want to create, you can do that. Then one thing comes as linspace. So linspace, what linspace is doing? So suppose I would need um, numbers from 0 to 10, and I need 8 numbers between 0 to 10. Okay, so first number is no 0, last number is 8, last number is 10, and between 0 and 10 there will be 6 more numbers. So since this is there are 8 numbers to be required, so first is 0, last is this number, and then there will be 6 more numbers between 0 and
0
10.
and
So you
10.
can, yeah, so you can see here it is showing me 6 more numbers over here, and this will be the equal distance number. So if you will subtract this minus this, it will be 1.4. Subtract this minus this, it will be 1.4. Subtract this minus this, it will be 1.4. So these all are the equal distant numbers.
Okay. This is used
Okay.
for
Sorry.
this line space is used for.
So line space is used for creating the resolution points when we have to work with the resolution of the data, or resolution of the image. Then we use this linear space function. Okay. Then if you have to create an identity matrix. So what is identity matrix? Identity matrix is basically when diagonal is 1. That's what is identity matrix. So you can use I function to create the identity matrix.
Okay.
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 Then there is random number. So if you have to generate the random numbers between 0 and 1, so we can use random dot rand. So it will generate the random numbers between 0 and 1. So I have given 15 random numbers. So it has generated 15 random numbers between 0 and 1. In the same way, I have given random dot rand in 4 cross 2. So basically, it is generating 8 random numbers with 4 cross 2 formation. Okay. Then I'm generating rand n. So rand n is generating the numbers between -1 and +1. Okay. So when it will be generating the number between -1 and +1, it will generate like this. So in 5 cross 2 formation, it is generating the number between -1 to +1. So this is how you can generate the random numbers between 0 to 1 or -1 to +1. So for 0 to 1 rand, and for -1 to +1 rand n. Okay, clear? Okay, so next is generate random numbers of 9 elements. So I am taking just np dot random rand 12. Then and if you want to check, you can check the dimension of it, and you can just say how it is. Okay, then this is about how you can store the character values with the NumPy array. Now comes about indexing, ki how we can do the indexing of these NumPy array. So NumPy array creates the same indexing as they are in string or list, right? So whatever you do in case of indexing, it will follow same manner. So the indexing will start from 0 and it will go till number of values -1, right? So for example, here I have created a NumPy array np.arrange ranging from 0 to 50 with 3 jumps. Okay, so it has created 0, 3, 6, 9, 12, 15, 18. Now if I want the number at sixth index means seventh number. So seventh number is this. Right. So this is what it is returning me. So it works exactly same manner as it is working in the case of list. Now slicing or slicing operations are also working in the same way. So here, for example, we have 1 to 5. So 1 to 5, it will return all numbers from 1 to 5. From 8 onwards till last, it is returning all the numbers from 8. From starting to 6 index -1, so it is returning me that numbers, right? Now NumPy arrays are mutable. You can change any value at any point of time. So you can do that. Yeah, I have not created this in my ARR. That's why it is generating this error. Okay, now it will not. Okay. Then here you can create the NumPy array with a two dimension. So like this, I have supplied in two dimension has been generated. Okay. So basically, the slicing and dicing operations are working in the same manner as they work in the list or tuple or string. Okay. Now, if I have to access the elements of the array based on some condition, I have to apply some condition, and based on that, I have to get the data. So when you will be working in the real time data, working on the real time values or columns, so definitely you need to apply some filters, right? So how those filters can be applied with this? So here conditional indexing. Here I am giving ARR con or an np dot a range. I am creating a array values from 0 to 10. I am just creating. Right now, what I want is I want all the elements which are greater than 5, right? So if I'll just do like this, what it will do is it will do the comparison with all individual elements, and wherever condition is false, it will return false, and wherever condition is true, it will return true. So you can see here, this is false, this is false, this is false. Up to here, it is false. So this is up to here. Okay, first six numbers. So for first six numbers, it is returning false. But for last five numbers, this condition will become true. So it is returning me true for the five times. But I don't want this part really. What I want is wherever this condition is true, so it should show those numbers only. So it should show in output, it should show this part only. It should not show the true and false. I don't want that. I want just the numbers which are qualifying these conditions, right? So what I can do is I can simply supply this condition as a parameter. So here I am taking ARR cond. Inside this, as in indexing parameter, I am supplying this as a condition, right? So ARR of cond greater than 5. So once I have applied this, you can see here, it is printing all the numbers which are satisfying this condition. Understood? Understood, Sharmila?
Yes.
Okay. In the same way, I am applying the same condition. Means on the same array, I am applying another condition whether element is divided by two completely or not. Right. So I am applying this condition and checking. So it is returning me all the elements which are satisfying this condition. Okay. If you want all the elements which don't satisfy, means which are not divided by two completely, I'll just execute. It is showing me all the elements which are not completely divided by two. Okay. Okay. Is this clear? Are you able to follow with me?
Yes, I think so. Yes.
And then the same way, when I have to apply the multiple conditions, so I can apply the multiple conditions. So ARR of condition 5 and error of condition completely divided by 2 is equal to 0. So I am just executing this. So you can see here that is representing 6, 8, and 10 over here. Okay. तो इस तरह से आप अपनी कंडीशंस को यहाँ पे लगा सकते हैं, मल्टीपल कंडीशन को लगा सकते हैं, ठीक है। अब इसके बाद आता है नंपाई ब्रॉडकास्टिंग। सो ब्रॉडकास्टिंग क्या होता है कि जब हमें दो एरेज के बीच में कुछ ऑपरेशंस करने हैं, तो उसको हम ब्रॉडकास्टिंग बोलते हैं, राइट? या एरे के ऊपर कोई एक अलग से वैल्यू हमें अप्लाई करनी हो तो उसको भी
Are you talking
ब्रॉडकास्टिंग।
to me? Are you talking to
सॉरी
me?
सॉरी 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 सॉरी
Okay.
it just goes on in flow. So sorry. Yes, so we are just going to discuss the broadcasting. So when we have to apply some operations over the NumPy array, that's what is known as broadcasting. Basically, the mathematical operation I'm talking about, right? So for example, I have this 2D array, okay, and this shape is this, right? I am creating a scalar value over here. This is scalar value. This is 1D array. This is 2D array. I'm creating these three values. Okay. Now what I'm doing is I am just dividing all the numbers of this array by this scalar value, right? So what it will do is each element of this array will be divided by this scalar value and it will return. So what I'm doing, ARR 2D divided by the scalar, right? So since this scalar is the standalone element, it will divide all the elements one by one from this value. Okay. Okay. So this is one thing. Now I have array 1D and I have array 2D, right? So I am just multiplying. I am just multiplying or subtracting array 1D minus array 2D, right? So array 1D has value 10, 12, and 14. Array 2D has the value in four rows and three columns: 2, 3, 4, 4, 5, 6, 3, 4, 5, and 4, 3, 2. Now what I am doing is array 1D minus array 2D. So what it will do is 10 will be subtracted by 2, 12 will be subtracted by 3, 14 will be subtracted by 4. Next, 10 will be subtracted by 4, 12 will be subtracted by 5, and 14 will be subtracted by 6. In next, 10 will be subtracted by 3, 12 will be subtracted by 4, and 14 will be subtracted by 5, one by one, and so on, right? So, like this, when this will be applied, array 2D minus 1D I am taking. So you can see here it is showing me values according to that. Okay. Okay. Yes, no. Okay. So, but this is only possible with the certain limitation only. So here you can see this is 1 cross 3 and this is 4 cross 3. Now suppose this array is 2 cross 3, right? If this array becomes 2 cross 3, will it work with 4 cross 3? So ideally it will not work because let's see here. There is a I'm taking array as 11D and it is 2 cross 3 and I'm operating that with this. So array 2 cross array 2D minus array 11D I am doing. So it is telling that operands cannot be broadcasted together because of their shapes. Right, right. So if one is there, it can be handled with everyone. But if there are different operations are there, it cannot be handled. Okay. So basically, it needs the uniformity of the variable values for operation, and that's why it does not operate with each and every type. Clear? Clear?
Okay. Yes.
Okay, so in this way, you can do these broadcasting. In the same way, I am taking 4 cross 3 with the 1 cross 4. This will also not work. You can see here there are 4 rows, and this array there are in 4 columns, and in here there are only 4. Sorry, 3 columns are there. So if I try to do any operation together with these kind of array, it will not work. Right. So broadcasting works when there is a uniformity of the operations. If uniformity is not there, it will not do those operations. Uniformity in the sense, in this case, if you see, so 1D array with 4D array is allowed. Sorry, one row with 4 row is allowed. Right, one row with 3 row will be also allowed. One row with 4 row will also be allowed. But 2 row with 4 rows not allowed. 3 row with 4 row not allowed because uniformity is not getting maintained. That's why it is not allowing. Okay. Now there are some mathematical functions are there. So in mathematical functions, you can see here like I'm taking this np dot a range I am taking. So the minimum number, the maximum number, argument at minimum argument position and maximum argument position, it is returning me the position of the biggest argument and smallest argument. And you want to do some more, there like a square root, you can do that, a calculation, or mean or exponent value you want to calculate, you can do all those calculations with this. Okay. Then if you want to change the structure of any array, so for example, I am taking a element array of 15 element over here and I am reshaping this. So what I'm doing is array dot reshape. So this array dot reshape will be 0 to 15, 15 elements are there. Then it will be 5 cross 3. So here you have to, while reshaping, you have to keep in mind that this multiplication should match. So this 5 cross 3 is 15 and there are 15 elements. If this is not matching, it will not perform the reshaping. So I am just doing over here. So you can see here, this is the one dimension and this has been converted to 5 cross 3. If suppose I do this 5 cross 2, so it will generate an error because it is not matching. Multiplication of these two is not matching with the multiplication of these numbers. So that's why it is not giving me the proper value, right? Now, if I have the 2D array and I want to convert that 2D array into 1D array, so I can simply use flatten function. So flatten function will flat all the numbers of the array and it will convert it into one dimension array rather than the two dimension array. Okay, so these values can also be transposed from one form to another form. So suppose we have this 2D array which is looking like this, and I am now transforming this. So row will be converted to columns. So you can just use transpose function for this. Okay,
Mhm.
any doubt so far?
Mhm.
Any doubt so far?
No, Kushal.
Okay,
Hear me.
so so now there is merging and splitting of the array. So if you want to merge the arrays or concatenate the array, you can use this concatenate function, right? So we have two array X and array Y. We have two arrays, and I am just concatenating. So np dot concatenate function inside that array X and array Y I am concatenating. Now here this is the third parameter which says X is equal to 0. So X is equal to 0 means we have to merge the array row wise, right? Um, yeah, we have to merge the array row wise. Row wise means once the rows of one array gets completed, the second array's rows will be added after that, right? So here there are two arrays. This is one array. This is second array. When I have performed that np dot concatenate, it is showing me like this. So one array is completed over here. Then second array rows are here. Okay, so this is what is known as row-wise merging. If I just convert this axis is equal to 1, so you can see it will be merged column-wise. So once the columns of one array gets over, the columns of the second array will start. So you can see 1, 2, 3, 4, and then 21, 22, 23, 24, like that values have come. Okay, so this is what is the merging of the array row wise and column wise, right? In the same way, you can split. So for a split, there is horizontal split and vertical split. So horizontal split means suppose this is the array, you want to cut it from the middle. So this will be horizontal array. So this 1, 2, 5, 6, 21, 22, 25, 26 will be the one part, and 3, 4, 7, 8, 23, 24, 27, 28 will be the second part. So I am just using H split and I am dividing into two part. Okay, so that's why it is getting into this. Now it is very much necessary to keep in mind that you can divide the array into equal number of parts only. If you suppose try to divide it into three parts, it will okay, this is the array. If you try to divide into three parts, it will not entertain because array split does not result in equal division. right? So you have to keep in mind that you need to divide it into the equal part only. The same with edge split and same with the vertical split also. Okay. Okay. So this vertical split in two part I am dividing, so it will cut the array. So this will be the one part and this will be the second part, right? You can do a four part also in this, right? So once you can do four parts. You can see it is divided into four parts. This is first part, this is second part, this is third part, this is fourth part, right? So you can always divide into just equal part only. You cannot divide into unequal part. This you have to see, right? So this is basically when we do the cross validation. That's that time we use this split function. Okay. Are you clear with this? Whatever we have discussed so far.
Yes, I have to. Yes, I have to. I have to
Doubts
take
with
a look
this?
again. No, no, no. If I have a question, I'll come to you.
Okay, so this NumPy part is over. Now the pandas part has to be started. So tomorrow we'll start with the pandas part. Pandas part. Okay.
So can you please today itself you share this document and then the recording?
In 1 hour, the recording will be updated on the
Yes,
on this
after an
recording
hour.
portal. I'll share it after that. After this, just and put me a reminder message if I don't share it by maybe by 9. Just put me that reminder message. I'll